Hello and welcome to the podcast According to Sci-Faith, where we discuss topics revolving around the compatibility of science and faith. I'm Joshua Göcking and you're listening to According to Sci-Faith. Episode 62, the Physics Nobel Prize 2023 and lasers. So 2023 was also a year in which, of course, the Physics Nobel Prize was awarded. And in this year, it was awarded to three physicists. And they were Anne L'Huillier, I guess it is pronounced, I don't know, of the University of Lund, Pierre Agostini of the University of Ohio State University in Columbus, and Ferenc Krauss of the Ludwig Maximilians University in Munich. So they were awarded the Nobel Prize for their research on attosecond light pulses, which is a pretty interesting topic, pretty groundbreaking research. So attoseconds, it's a really small number. So just to illustrate this, you might know milli, you might even know micro and nano. So those are steps you can go to show how small a thing is. So milli is, for example, a thousandth, and then it goes in 1,000 steps. So micro would be a millionth, and then nano is a billionth. And this way it continues. Afterwards there's pico, and then there's femto, and then there's atto. So atto is a really small amount, and it is really difficult to get to such a small layer for once, because this is the level at which atoms move in electrons move in atoms. So it's a really short period, and it used to be not accessible by light or by lasers. But before we describe how they did it, how they made this possible, I think it's best to first explain how a laser works and what a laser actually is. So let us talk a little bit about lasers. So first, what does laser stand for? Laser sounds cool, the word, but where does this word come from? And actually, laser is an abbreviation. So if you write it out, it stands for light amplification by stimulated emission of radiation. So this is what laser stands for. But what does this mean? So now we know what the abbreviation means, but maybe we are not the smarter unless you really know about the physical concepts behind it. So first, we start by explaining first the latter part, the part of stimulated emission of radiation. So for this, we need to go back to physics class and remember, or even chemistry class, remember what we learned there. So we learned that matter is basically made up of atoms, and atoms itself are not the smallest part yet. They are themselves made up of protons, neutrons in their nucleus, and electrons in levels around those. And they can have certain states. They can be in a ground state, or they can be in upper states, depending on how much energy they have. So I think most of you should know this back from school, that there are those different layers in which the or orbitals in which the electrons can be. And what then happens is that they can jump from one layer to another. If they absorb energy, they can go to a higher level, and if they give this energy back, they can jump to a lower level. And of course, electrons, or everything in nature, is always trying to reduce the amount of energy it needs for something. So it generally tends to go to the ground state, to the lowest state of energy. But there are simple rules that, so for example, if you have an atom with more than just one or two electrons, like hydrogen, which only has one electron, but if you have like carbon, it has more than that. So if you have those, then there are physics rules about what is allowed. For example, you cannot have two particles in the same energetic level. So this is this is just forbidden by that this is the reason for this is that particles are matter particles are fermions, and fermions have this for fermions the Pauli exclusion principle holds, which basically states that two particles cannot be in the same energetic state. They have to be different in so-called quantum numbers, and they can be actually two can be in kind of the same energetic states because they have their own property called spin, and if they are different in this property, they can be in the same energetic state but with reversed spins. So therefore, for example, if you know from your chemistry or physics class, in the lowest energy level of those atoms, there were always two electrons that could fit in there, and this is exactly the reason for it. They differ in their spins, and therefore they can be there. As you might know, in the upper layers, usually there were 8 who could fit in there, and this is for different reasons because there are different particle numbers that they can obtain. They can have their own angular momentum, and they can have different levels there. So there is more possibilities of different energy levels in those areas. So I hope this was not too complex, but this is basically the atomic model you learned in school, I guess. And now we want to describe this further, because now the question is, what can always happen, for example, is that one electron by some energy that it absorbs can get to an excited state, which we call it. So it can go from a lower level to a higher level by some excitation, usually using photons or light particles. And now let's assume we have such an atom where the electron is in an excited state. And now the electron decides, let's say, to go back to the ground state. So what it does is it goes back to the ground state, but now we know energy is conserved in physics always. Energy has to be conserved. So how can this be that it goes to this ground state? Because the ground state is less energetic than the excited state. So where does this energy go? It has to be released in some way, right? And the way in which this is released is by giving off light, giving off a photon, a light particle. And this can happen spontaneously, as we just described, but it can also happen stimulatedly. But this we will describe in a bit. So it will give off this light, and now you know that from quantum mechanics we know that these atomic levels we have there, they are quantized. So they are at a specific energy level. This is not a spectrum where there's a continuous amount of levels. They are at specific energy levels. So it is a specific amount of energy that it takes from one atomic level to the lower atomic level. So there's a specific amount of energy. And now, if you know of the photoelectric effect, you know that energy for light, because light is emitted when an electron jumps from one level to another, to a lower level. So light, the energy of light is proportional to its frequency. So if you have high energetic light, then it will have a high frequency. If you have low energetic light, it will have a low frequency. So and the different frequencies of light you can see as different colors. So if it's in the visible spectrum, so the colors of light have different frequencies. So red light has a lower frequency, and blue and violet light has a higher frequency, and therefore you know also infrared is in the area of frequencies lower than what we can see, of light of frequencies lower that we can see, and ultraviolet light is in the frequency spectrum of frequencies higher than is visible to our eyes. So this is the way it works, and therefore each atom has, with its individual levels of energy differences between its atomic layers, has also individual photons of light that it emits when it jumps from one level to another. So there is a spectrum for each atom of these differences in light. So where these difference in energy corresponds to a certain photon that is emitted, and this has a certain frequency. And so you have, in this way, you have a light spectrum for every atom, and this is really important. For example, also in astronomic observations, when we see the light that we observe from other stars or from other objects, then we can know which elements they are made of, because we know this is the light of this and that part. For example, we know this light comes from is from the energy level of hydrogen, and so we know that it was originally emitted from an hydrogen atom. But this was a big little bit lost track, but I think it was really good to understand this, because now we know how light is emitted from an atom. The problem with what we now described spontaneous emission, is if an electron spontaneously decides to emit radiation, then the direction in which it is emitted is completely random. So there is no way of foretelling in which direction the light will be emitted. It will just be any direction. So this is, in a laser, this is really not what we want. We wanted to have a certain direction such that we can use this light to point it somewhere. Therefore, we need to find another way of getting this light to be emitted. And there, luckily, is the effect of stimulated emission. And this is also happens with atoms. And this is happening, let's say we have an atom in an excited state, and there is a photon coming towards it. And instead of the electron absorbing it and jumping to an even higher energetic level, it is triggered by this photon to jump to a lower level and emit radiation. Like if it would spontaneously emit radiation, but this way it is induced by this other photon. And in this case, we get this effect that the photon that the electron will then emit will point in the same direction as the photon that induced this emission. And this is what we mean in what the SIR part of the laser is, the stimulated emission of radiation. So what happens in a laser is that what specifically happens, we will see in a bit, but there are these emissions stimulated by photons, and then they move in the same direction. So what is now missing is the light amplification. So we not only want to stimulate emissions of individual photons, we want to have a lot of light. We want to have, lasers usually have a lot of light that they emit, not only individual photons, which would be nothing, because it would just be too few photons to use for us. Especially if you have those high-powered lasers who can even cut through materials and so on. So we need an amplification of this light. You want to have a lot of this light. And how do we achieve this? This is achieved by a so-called process called population inversion. So basically, as we have said, atoms or electrons always want to be in the lowest state. So they always jump from the highest to the lowest states in order to reduce the energy they need. So this we want to turn around. We want to invert this population, basically, the population of the electrons in the atom. And this is done through a pump mechanism which enforces this population inversion. And this works, for example, that there's by absorption of photons, which always pulls the electrons in higher levels, higher energy levels, and then they jump back to a lower state, and there you get always the stimulated emission of radiation. But there is not, what is not usually used is a two-level system where you have the ground state and an excited state, because it can be shown that in this way population inversion cannot be upheld, and therefore usually a 3 or 4 level scheme is used, where you excite in a level state scheme, you excite the particle from the ground state to a higher excited state, from which it then decays into a lower state, which is not the ground state. So there you have these 3 levels, and this way you can hold up such a population inversion. And this is usually how you get this laser to work, that you have it overly populate an excited atomic energy state, and from this you stimulate the emission to this or photons to this lower state, which is not a ground state in this 3 level scheme, and this light is then emitted, and what happens to the light we come to later. All right, I think it's time for a short break. So before we continue, just make me some short announcements. If you want to know more about Sci-Faith, I really encourage you to go to my website, sci-faith.de/en. There you can find out more about this podcast, about my book, and about my blog. So you can read my blog. All the articles are also now in English, so you can read all of them. Also the article which I've described in the first episode. And you can also learn more about my book, which is now available in English. So I really encourage you to get it as an ebook and read it, because there really much about what we are talking about is really discussed in a deeper way, and you will understand, I think, a lot more of what I'm talking about if you really have grasped those concepts. Also, there is a new book out, my latest novel, or my first novel also, Alien Thoughts. You can get it on Amazon as an ebook, and I really encourage you to read it. It's really exciting. I have gotten a lot of feedbacks. People really like it, and so I really hope you read it and also give it a 5-star rating, because this always helps people to know what a book is, to understand if it is something for them. And really, if you have the time, I really ask you to write a review of it, such that people really can know what a book is about, know if it's something for them, and so more readers can get aware of this book and can get to enjoy it. It also, of course, all this also supports me in my work, also on this podcast. It gives me more flexibility to produce new episodes. So I really am hoping for your support. Also, if you have ideas or requests or something that you want to have covered in this podcast, feel free to contact me at sci-faith.de/en and then use the contact form. There you can also subscribe to the newsletter, where you will get some special materials. So in the newsletter I write some of the thoughts that are usually not fit for blog posts, but still very interesting topics. So if you want to get this or get news, what happens at Sci-Faith, what's new, what's up, then you will get the latest news. You will really get there, and then I really encourage you to subscribe to my Substack. With that being said, let's continue to the episode. Now I want to shortly interpret this in a spiritual way, because I think this shows us also something for the spiritual way life, or for our life in the spirit, for our life with Christ, because it shows that, if you think about it, everything going to the lowest energy, everything always trying to reduce its energy, to reduce its amount. It's kind of the way the world works. It's kind of how we see everything. Kind of also, if you look into the law of inertia, everything seems to be inert, seems to be trying to move as little as possible. I mean, it's physically not completely right. I get it. It's, if something is pretty fast, it tries to stay that fast, of course. But you have in it this, if you also know it from what you would talk to people around. If you talk of somebody who is a nerd, then it's somebody who's really not getting to move and really not getting things going, and which is considered to be a negative thing. Of course, you can interpret physics always in two directions, but if you would interpret it in this way, then you can also see that this population inversion is something which tries to turn this around, tries to turn us against this this way of the world, the way the world works, to always be inert, to just go along, to just go the easiest way, go the way with the least resistance, and so on. So I think what the Spirit wants us and what God wants us to be with being part of this new creation, he wants to invert this population. He wants to invert us in such a way that we don't go with the way of the least resistance, the way of least effort, the easiest way, in a negative way. Of course, he does not want us to work harder than we have to do stupid efforts which could be achieved in an easier way. He wants us to work smart and to act smartly, but he does not want us to go this way where we abstain from effort, where we try to go the easiest way, and in which, as you have some experience to later realize, which is actually the way of most effort, of most fighting and so on, because in the long run it will get you more effort because you have been lazy before. So this is I think what he wants to tell us, and there you see it also with the laser. There is a pump mechanism, and this pump mechanism, this delivers the energy. It excites these particles to this higher state. It delivers the energy for these particles to go to this higher state and to populate this higher state and stay in this higher state. So there it is, of course, also so that you don't need to make this effort yourself. You as the electron in this picture do not need to pull your self up from your bootstrap, but you are pulled there by the power of God, by the power of this pump mechanism, which in this image would be the power of God. So this is what you can see there. And also, if you look at it big biblical, you always see that God wants us to be in the high places, above everything. In Ephesians it says that we are placed in heavenly places, so where we are above all these worldly things. And I think this is also what this shows us, is that he wants us to be in the high energetic ways, where we are highly energetic, where we are not in the ground state and moved around by the ways of this world, but where we are above those things, where we are not in the sense that we are something better, but in a sense that we are transferred into his kingdom, and where we are concerned with his kingdom and not the ways of this natural world. So I think this is a pretty powerful picture in the Spirit way, where it shows that what he wants to do be us. And if you think this image further, you also see what happens if this occurs. What happens? Light is emitted. So, light is emitted. Okay, the electrons then go to a lower state. This is maybe not part of the picture, but light is emitted. So we become the light of the world by being in this excited state, by being in this high state, by letting our population be inverted. We become the light. We become the light of the world, as Jesus says it, and we become alive to those who are not yet in this position, who are not yet aware of this possibility, who are not yet living in the power of God, and therefore are in this excited state. So I think this is a pretty powerful picture for what God wants to do with us and where he wants us to live. So to continue with the laser, what happens afterwards when all this light is emitted? Then they come into resonators to get them to a unified frequency. As I said, they have one frequency, but they still can by different radiations. So if some electrons do not use the 3-level scheme, but still jump to another energy level and so on, which can all happen, then you have a lot of noise in there, and you want to get rid of that. And this you do by resonators. This is basically two mirrors who are opposite to each other, and they are positioned in such a distance that when they are reflected, that everything but the frequency that you want to have obtained will be cancelled out by interference effects. And this way you have two mirrors, but you of course, you don't want the light to just bang and bang around between those mirrors until the frequency is clean, but they just jumping around between the mirrors and nothing else happens. No, of course, the light has to come out at some place. So therefore, one of those mirrors is not completely reflecting, but to something like 99%. And so 1% of the light that is in this way put into a unified frequency will get out and come out of the laser. So this is the basic working of the laser. So I hope you could understand it in some aspects. So if not, then feel free to ask a question after this podcast episode. And what the problem with this is that this is on the area of femtoseconds. So one swing of one period of light is already on the area of femtoseconds. So it's too long to achieve attoseconds, which they achieved in their Nobel Prize winning research. So what did they do? So what they did is they radiated laser on matter. And as with the guitar, where you have, if you let something resonate, you have these harmonics that occur, or if you have they are in their frequency a lot of shorter than the original tone that you got. And in the same way, this happens if you put these laser pulses on matter, and there are shorter frequencies reflected or coming out of this matter, and this allowed to achieve attosecond pulses. So this is really pretty simplified, but I think that was the concept behind it. And today they even managed to get laser pulses as short as 50 attoseconds, which is really, really short. Just to illustrate this, in this time, light, which has, as we know, the highest speed, the light speed is the speed limit basically of the universe, and in this time, in 50 attoseconds, the light with the highest speed travels a little bit more than the diameter of our DNA, and our DNA is 15 nanometers is the diameter of our DNA. So it's really, really small, and so this 50 attoseconds is really, really short, and this shows how much of an achievement this is, and this is really groundbreaking research. It has is assumed to have a lot of technical applications, but it's also for research really a breakthrough, because it allows a lot of things to be researched, and therefore especially in regarding reactions, chemical reactions and so forth, because everything that happens there happens on these time scales. So this was a really groundbreaking research, and therefore the Nobel Prize was well deserved, and I hope you could understand to some degree what this was about and what really was achieved there. So that's everything for today's episode. I hope you liked it and you enjoyed each part of it. If you want to get in touch with me or discuss a topic or want to give me some feedback, then feel free to contact me using the contact form on my website, sci-faith.de/en. And there you can go to the contact tab and contact me. And if you have any other things or episodes you want to have covered there, or topics you want to have covered, feel free to contact me there. Also, if you are not yet familiar with the format in which this podcast is produced, let me just briefly explain it to you. So there always at the beginning of a month or of a block, there is a big block of 4 episodes in one thing. It's kind of like a preview, which I call it, where you have the next 4 episodes all in one episode together, combined. And this is for people who like to hear long format podcasts, who have a long way to work or something else, where they can listen to a long episode and can then have a preview of the next 4 episodes all at once, and are completely up to date from the beginning of the blog. For those who like their episodes shorter, who prefer it if they have a half an hour or even less of a podcast episode, for those there is every week afterwards will appear a podcast episode almost in that length, and this way I can publish every week a new podcast every episode, and everyone can have it his own way, either once a month a long chunk of content, or once a week a shorter format podcast episode. So I think that's the best way for everyone, and also for me when I'm producing it. Please also note that this is an independent podcast, which means that it is recorded, produced, and marketed by me. So I really need your support in this. So if you like this podcast, then give it a 5-star rating. And if you have the time, even write a review to it. This just helps other listeners to become aware of this podcast. And then people who might be interested in this content can become aware of it. Also, if you have friends who you think would like this content, then recommend it to them and share it with them. Also, you can support me in other ways, for example by reading my blog and subscribing to my newsletter, or even by reading my books, which you can find on Amazon. For example, there is my latest novel out now is Alien Thoughts, which is pretty entertaining from the feedback that I gotten, and so it's also in some way related to science and faith. The topic of it is also in there, but of course you can also read the book to this podcast, Sci-Faith, The Compatibility of Science and Faith, which is also available in English since last year. Thank you for that, and now I wish you a wonderful day, and I'm looking forward for you to tune in again next time.